Okay, we're back for the last video. This one's going to cover all the GPU stuff in the on how to run and compile GPU codes. So I'm going to go into the next directory, which is called GPU examples, and I have 6 different examples, all kind of exercising different features. And one thing you need to know that when you do the let me do a module list. You'll notice that we don't have any of the accelerator modules loaded. So I'm going to load the accelerator modules. And then I'm going to go into the first example. Again, these are all actually kind of boring. From an executable perspective, they're very simple codes. And these two are giving a warning message. They do execute correctly. They are giving an error message that I'm still trying to resolve. So don't worry about it. But they're still running. And these first couple examples are going to use the Pgi compiler. So I'm going to go ahead and swap from the Cray to the Pgi compiler. And I've set up these 6 examples all very similarly. So you do a make clean, and then you do a make, and several of these examples will have both Fortran and C versions. So it'll be compiling it twice. And if I look at the directory, you can see that I have a Fortran version and a C version. And then I have this, I'm going to go ahead and launch my job. Then we can look at the file. So you can see that I'm going to launch it. Oh, here's my resources. So again, it's pretty much the same. You're asking for nodes and the number of cores per node. We're going to use 16 cores per node now because the GPU nodes have only one socket, whereas the CPU nodes had 2 sockets. So there's only 16 cores per GPU node. And this is a new command to you guys, is that I'm going to actually specify that this job run in a particular queue, and it's the GPU queue, so that I know that I get a GPU for this job. And I'm going to bet that it's done, and there it is. And if I look at the output, it's not very exciting. Here's this error message. It's talking about an incompatibility between modules, so that should be resolved automatically very shortly. But basically, here's the output from the Fortran and the output from the C. So that the program, if you look at the source code, I won't go through it now, but it does some kind of an operation, and it does a check to make sure that it get the right answer. And when it does, it prints out that it got the right answer. So not very exciting. We're going to go back, and now we're going to do exercise 2. We're going to make a clean directory. We're going to go ahead and make our codes. And again, the point of these examples is that you're going to be getting these tar files and all the output, so that you can walk through all these by yourself and then actually study the code and understand what's going on. Here's the C version and the Fortran version, the executables again. I'm going to head and submit the job. Go ahead and see our job in the queue. There it is. And this is what the job is actually doing. This one's a little interesting. So we're actually launching this on 4 nodes. So this is an example of running an MPI job, where each rank is then going to call a GPU. And this was kind of interesting. When I first was playing with this, I forgot to use this -N1, and what it did was it put all 4 ranks on the same node, and then that node tried to talk to 4 GPUs, but there was only 1 GPU attached to it, so it was giving me all kinds of errors. So I remembered to put this -N1 on. That says only use 1 core per node. And then I also modified the code. Let me see if it's done. It's done. And so I also modified the code and says, well, go ahead and tell me, what node did I run on? So that I know that it ran on 4 unique nodes. And again, very boring. 4 ranks, and each one got the right answer. Okay, here's example 3. Same story. We're going to do a make clean. We're going to do a make. And this one's using OpenCL. And we're going to launch our job. You can see that I have a brand new executable, so I successfully compiled it. Nothing interesting in this job. It's only going to run it once, and one node, one GPU. There's my job running. Completed. And again, these are simple examples just to show. So I got the right answers. Let's do example 4. So these final 3 examples are going to use the Pgi compiler, so I'm going to swap back. And I didn't create these examples. The developer who created them wrote them in such a way that he preferred one compiler over the other. So I just went ahead and used it the way they are. But it does give you a nice variation showing different compilers. I've gotten these warnings before. I haven't figured out the cause of them. But it does create an executable. There's my executable. I'm going to launch my job. This is what my launch looks like. It's running. Trying to remember. I think this one actually does calculate something interesting. There it is. It's done. Oh, so it runs it multiple times, and it gives you whether or not it passed with an error tolerance, and it runs it on the CPU and the GPU, and gives you a feel for what kind of speed up you're getting between the CPU and the GPU. All right, 2 more examples. Here's an OpenACC example. We're going to do a make clean, a make. Going to launch the job. This one has two versions again, the C and the Fortran. Let's see where our job's at. We're in the queue. You'll notice on the output here that we are in the GPU queue. I believe that's what that column is telling us. We could do an xt node stat. Let's see if we can get lucky here and find my job. There it is. So my job is called CUDA exec. It's in the run state, and I'm BO. And if I could find BO in this list here, it's going to be tough because it's going to be one. Well, I'll leave that for an exercise for a reader, but you can actually tell which node, which blade you're running on. If I check my job, it's completed, and this was example 5. And again, boring output, but I got the right answers. And then let's look at the OpenACC example with libsci. Gonna make. Gonna go ahead and submit the job. This one gives a couple of warnings also, but we can see that we have an executable, a brand new executable. The job is launched. It's running. So hopefully you can dig through the source code here and understand how to compile for the GPU, or take these examples and just try to build upon them. And it's still running. No, I want I don't see it, so I think it might have finished before I was able to get there. Yep, it's done. And here's our last job. And you can see that it calculated some kind of an error for this is the Fortran test, and it's comparing a DGEM with the accelerator versus the CPU, and it's doing quite well. All right, that's it. Not very exciting on these last GPU examples, but again, the key here is that you have the source codes, so you can look at how they coded up the GPU work, and you have the compile commands, and you have the launch scripts. So you should be able to replicate this work and then understand how you can do it for your jobs. Thank you for listening, and hope these videos are useful. Goodbye.